linear inequalities. We started with a lot of different forms of linear equations. Standard form, slope-intercept form, okay? Graphing them, finding intercepts, finding slope. A lot of that is still going to keep going, but now we have an inequality instead of an equation, okay? So I want you to think back. When we first started solving one variable inequality, or equations and one variable inequalities, one variable equations, we had one answer, a value, okay? X equals 2. When we moved into one variable inequalities, then we had a range of numbers. X is greater than 2, or X is less than or equal to 2, okay? Similar concept moving from linear equations to linear inequalities in two variables. Linear equations, the solution is all the points on the line. Linear inequalities, we still have that line, but now we're moving to points that are outside of that line, okay? And we usually look at one side of the line or the other side of the line, okay? Values that are greater than the line or less than the line. Values that are greater than or equal to the line or less than or equal to the line, okay? So when we're dealing with inequalities, we're dealing with shading. So we can take the same setup that we have for a standard equation, but instead of an equal sign, we have an inequality sign. And it could be less than, it could be greater than. It could be less than or equal to, it could be greater than or equal to. Now, think back, we have our inequality signs, okay? So we have less than, we have greater than, we have less than or equal to, greater than or equal to. When we graphed something like x is greater than 2 on a number line, we used either an open circle or a closed circle. Which set of symbols used the open and which one used the closed? And that said, hey, this number is included in my solution. Okay, so x is greater than or equal to 2. All the numbers larger than 2 make it true, but 2 also makes it true. Open circle for the less than or the greater than. When we're dealing with a line, we have to have something that represents a similar concept. So if it's less than a line but not equal to, we use a dotted line when we are graphing. If it's less than or equal to, greater than or equal to, we use a solid line when graphing. Okay, so that's going to be one of the major differences, is now we're going to be graphing lines, but we're going to be using either a dotted line or a solid line. Point of order, one, is when you are graphing your lines and it's dotted, please make sure that it is as clear as day that it is a dotted line, because sometimes it gets really hard for me to tell, especially if you've done a lot of erasing. I can't necessarily tell whether it's dotted or not. Clear that you're graphing a dotted line versus a solid line. Okay? So let's go into graphing. First, we start by graphing the line. The easiest way, 9 times out of 10, actually I would even go 99 times out of 100, is rewrite your equation in slope-intercept form. We treat this exactly the same as an equation, except I have that greater than sign in there. Okay, that's just replacing. So if I want this in slope-intercept form, what do I have to do to that equation? Subtract 3x. Because I want y by itself. So I get a new equation of y is greater than negative 3x minus 4. Okay? Y is greater than negative 3x minus 4. So I can plot my y-intercept. What is my y-intercept?
Negative 4.
Close.
3x.
We're close with the negative 4.
Oh, 4.
It's a point.
0. Oh, 0.
0, negative 4. 0, negative 4. It's a point. Okay, y-intercept is a point. That's a 3. 1, 2, 3, 4. There we go. I can count. Okay, so there's my y-intercept, 0, negative 4. All right, what's my slope? Negative 3 over 1.
Oh, yeah, I do that too.
So I have y-intercept of 0, negative 4. I have a slope of negative 3 over 1. So what is that? How do I get to my next point from my y-intercept?
You go up 3 and over 1. Wait, just.
Is that better?
Yeah, that's
Good. 1, 2, 3, right 1. I could also go up 3, left 1. And that gives me a set of points. Now, if I have y is greater than my line, am I going to use a dotted or a solid line? Dotted. Okay? Because remember, our less than and our greater than uses dotted. Less than or equal to, greater than or equal to, solid. So we'll use a dotted line. I'm going to make sure that it's clearly dotted. And also, some of you are forgetting to put arrows at the end of your lines. You need to put arrows at the end of your lines because that's how you indicate that the line keeps going. If you don't put arrows at the end of the line, then it's a line segment and it stops. Yes, sir. So I'm just plotting those as like identifying where my line's going to go. Yes, they would be open, but I don't really need them. So I could, as long as your lines are dashed, I'm not going to be that picky about it. So I mean that's technically our line right there. Okay. As long as your line is dashed, I'm not going to be that picky. Those points are just there for guiding. Yeah. Okay. That would be the most accurate representation there. Consider those dots as dashes. Okay. All right. So there's our line. There we go. All right. So now I need to figure out. Use the dashed line. Now we need to figure out where to shade. Okay, because an inequality says that it's not just the points on the line. I have points on one side. All the points on one side of the line are going to make this inequality true. Either everything that's up on this top right area and beyond, or everything that's on the bottom left and beyond. Okay? So there's an easy way and then a way to check it. If you write it in slope-intercept form, you can look at the equation and ask yourself where the shading is going to be. So my equation is, or my inequality is that, I did not want an eraser. Whoopsies. Y is greater than or equal to negative 3x minus 4. Let's try that one more time with a highlighter. Okay? I can look at this and say, y is greater than my line. Y is greater than my line. So if I have my line, and I want all the y values that are greater than it, am I going to shade above or below? These are all the line y values that are greater than my line. So my shading, I swear that's finicky today. My shading is going to be above my line. And what this says is that all of those points make that inequality true. Every single one of those points and beyond makes that inequality true. All right? Those are all of the solutions. And we can test it. So let's test it. Pick a point that is not on your line. Pick a point that is not on your line. And that part's really important.
3, 4.
That all of these points are solutions to that inequality.
So it would be like -1, -5 would be not on the line.
Yeah. Okay. Now, any point not on the line wins. Okay, but always make it easier make it as easy as possible. Easiest point ever that I can is 0, 0.
But I thought if it was in the shade,
No, literally on the line. Literally on the line. Literally not on the line.
oh,
This is a region. Okay, pick a point that's not on the line itself. Anything that's not on the line. Okay, so anything, and preferably in the shaded regions. Okay. So pick a point not on the line, preferably in the shaded region. 0, 0 is the easiest point. Okay. So if I'm saying that all of these points are my solution, everything in that shaded area is going to make this inequality true, then that means the point 0, 0 will make this inequality true. So to check it, I'm going to take the point 0, 0, and I'm going to sub it in to my original inequality. 3 times 0 plus 0 should be greater than negative 4. 0 is greater than negative 4. Is that a true statement?
Yeah. No.
Yes. 0 is greater than all of my negative values. So since that statement is true, I did my shading correctly. If I ended up with a false statement, then I might need to switch my shading to the other side. And I can pick a point on the other side and test it to make sure it's true. Okay? I could plug in any point over here. I could plug in 3, 5. I could plug in, 5, 2. I could plug in 7, 0. Any of those points, I could plug into this inequality and it will give me a true statement. But my solution set is this entire side of the graph. Forever and ever and ever and ever and ever. Shading forever. Okay? Okay. What's the first thing I need to do with this equation in order to be able to graph it? Okay? Because what am I trying to do to that equation? Yep. Get y by itself, slope-intercept form. So we're going to get it as 5y less than or equal to negative 3x minus 2. Is it in slope-intercept form yet?
No.
Nope. What do I need to do next? Divide everything by 5. So then it turns into y is less than or equal to negative 3/5 x minus 2/5. Okay? Divide everything by 5. We're going to have some fractions. All right? Where is my y-intercept?
Negative 2/5.
0, negative 2/5. You understand the core of it. That's good. It's just a little detail to finish it off. Okay? So my y-intercept is 0, negative 2/5. So I can plot that point. It's going to be right about here. Close enough. 2/5 is almost a half. So doesn't have to be perfect. All right? How am I going to find my next point? Okay, what's my slope? Negative 3/5. So using that, how do I get to my next point?
Go down 3.
Good. So 1, 2, 3, 1, 2, 3, 4, 5. How can I get another point in the opposite direction?
Up 5 left.
Okay. Solid line or dashed line?
Solid.
Solid. How do I know it's solid?
Because it's a equality.
Less than or equals to. Solid line. So let's draw our solid line. You like the sound effects?
Yes.
Do they help? Good. Alright. Alright. So, looking at my inequality, okay, over here, in slope-intercept form, okay? So what I wrote in slope-intercept form, y is less than or equal to my line. So am I going to shade above or below? Below. Y is less than the line, so I want to shade below. Alright? Let's pick a point to test. What's the easiest point to pick? 0, 0. So here's 0, 0. Is 0, 0... No, I don't want that. Go away. Apparently I can caption this. That's interesting. I don't know how to stop that. I know, it's still going. That's fun. Maybe it was that button? Was it that one? Maybe we can do this? Sure, let's keep that. We'll start this again. That was fun. That was an adventure. I need to explore that more. Alright. Where was I? Here, pen. Good. So the point 0, 0. Is 0, 0 in my solution set? Is it where I have my shading? No. So if I plug 0, 0 into my original inequality, do I expect it to be true or false?
False.
False. Let's make sure. Okay? So 3 times 0 plus 5 times 0 is less than or equal to negative 2. So this should be false. I should get false. Should get a false statement. Okay? Do you all understand why we should get a false statement?
It's not in the shaded area.
Not in the shaded area. Good. Okay? So I have 3 times 0 is 0, plus 0 is 0, equals negative 2, or less than or equal. Is 0 less than or equal to negative 2? No. False statement. That means my shading is correct. If I picked a point in the shading, it would give me a true statement. So if I picked negative 1, negative 1, that's in my shading. I should get a true statement. Okay? So 3 times negative 1 plus 5 times negative 1 should be less than or equal to negative 2. I get negative 8 is less than or equal to negative 2. Is that a true statement?
Yes.
Yeah. Again, just verifying my shading. Okay? Great. Can you? All right. Questions on that?
So what would we write on the line?
The answer is the graph.
So for the
You will have to graph it.
line,
Yeah. The answer, quote unquote, when you are dealing with a linear inequality, it's the graph. Okay? Now, we could do an extension of it, and I could ask, is negative 5, 3 a solution to my inequality? Is negative 5, 3 a solution to my inequality? Where's negative 5, 3? Oh, here? Is that a solution to my inequality? No. The graph to see that, or we can plug it in to see if it's true. But generally, it's going to say, hey, I want you to graph this inequality. The solution is the graph. All of this other stuff in green is me checking to make sure that my graph is right. Okay? All right. Graph 3x is less than 5, which is similar to the equation 3x equals 5. So how do I get x by itself? Divide by 3. So I get x is less than 5. All right? If I have x equals a number, what type of line do I get? I get a vertical line. At this point, it's going to be a vertical line at 5. So 1, 2, 3, 4, 5. A vertical line at 5. What type of line should I have? Dashed. Let me fix that. Why is it dashed, Beatrice? It's a less than, not a less than or equals. All right, so I got a dashed line at 5, x equals 5. Okay, remember to draw your arrows. Make sure the dash is clear. Okay, draw it as a dashed line. X equals a number is vertical. All right. So we'll pick a test point, but I want to think about what my shading's probably going to be, and we're going to verify it with a test point. All right. So looking at my inequality, x is less than 5. Is that to the left of my line or to the right of my line? To the left of my line. So my shading should be all of this. Okay? What test point should we pick? Pick the origin. 0, 0. That's our easiest one, right? So 0, 0. Again, I just have to make sure it's not on my line. 0, 0 is not on my line. Okay? So I'm good. So let's plug it into the original inequality. 3 times 0 less than 15. Should I expect a true or a false statement? I should expect a true. Is it true? Yes. So then the shading's good. Okay? I should get a true statement. I did get a true statement. My shading is good. All right? The inequality. If you don't have a or equal to, it's dashed. Last two are going to be intersection and a union. Okay? Intersection. Intersection of a road. Where the two roads meet. Where the two roads are the same. Where the two roads overlap. The intersection. Intersection of inequality is where our two shaded regions overlap. where the two shaded regions meet. So we're going to graph both of those, and we're going to look at where the shaded regions are going to be, and we want to find the section where they overlap. So I start with x is greater than 1. What type of line is that going to be? X is greater than or equal to 1. Vertical. And solid or dotted? Solid. Okay. Solid line. It's going to be solid for both of those, right? Okay. So solid vertical line. Okay. Now, I'm just going to do kind of a partial shading just to get an idea of where my solution is going to be. Okay? Because I have to figure out where they overlap. So I first need to know where each one's going to go on its own. So x is greater than or equal to 1. Is that going to be the left or the right? It's going to be the right. X is greater than. Okay? So my shading is going to be on this side. But I don't want to do the full thing because that's not all of the answers over there. But I just want to mark, okay, it's going to be on the right side. Okay? So the solution to x is greater than 1 is this whole area to the right. Now let's graph. Let's do that. Okay. We've already got slope-intercept form, so that's lucky. Okay, where am I going to start?
0, -1.
0, -1. Good job. Okay. And then my slope, how am I going to get my next point? 2, right 1. Good. Good. Here, and then down to left 1. Continue the pattern. We already know it's going to be a solid line. Here we go. Okay? So now let's look at our shading again. Okay? So y is greater than my line. Is that above or below? Above. Y is greater than my line. So above. Okay? So I have 4 regions that are created by the intersection of these two lines. I have 4 regions. Okay? So over on the right, I have this region here. Okay? This region here. That's separated, created by this angle here. Okay? I have this region to the right. I have this region to the left. Okay? This region to the left, created by this angle. I have this region above, created by this angle. All of this up here. And then I have this region below, created by that angle there. So all of this. Okay? I'm going to label these just so you can tell me more easily. If it would let me change back to a pen.
So we need to shade all of that?
No. We're not going to shade all of it. Let's use purple. Okay? So I have region 1, region 2, region 3, region 4. Those numbers are completely arbitrary. Okay? So don't read into the numbers. What region has shading for both of those lines? Region 3. Region 3 has shading for both of those lines. So my intersection is the region that has both shadings. So my intersection, I would only have this as my solution set. That's the region where my solution is. Okay? Now, we always want to check. Okay? Now, with intersections, we have to be more specific about the point that we check. Can't just always default to 0, 0. I want to check a point that is in the overlap. Okay? I have to pick a point that's in the overlap. Now, we can pick whatever the easiest one might be. Let's say 2, 5. 2, 5 doesn't look that bad. Okay? I'm going to pick the point 2, 5 because that's in my shaded region. The point 2, 5 should make both inequalities true. Both of them true. 2, 5 should make both of them true. Okay? So if I have x is greater than 1, we plug in our x value of 2. Is that greater than 1? Yeah. Okay, that works. 5 should be greater than 2 times, what's my point? 2 minus 1. 5 should be greater than or equal to 3. Is that true? Yes. So then my shaded region checks out. If it didn't make both true, then I might need to reevaluate where my shaded region is. right, last one. Union. How does union differ from intersection? All of it together. Everything. Intersections where they overlap, where they're the same. Union is all of it together. All right? So we're going to have more shading on a union than on an intersection. So we're going to graph them both, like we normally would. Okay? Get this in slope-intercept form. Subtract x. So 1/2 y is greater than or equal to negative x minus 4. How do I get rid of my fractions?
Oh, divide the reciprocal.
Multiply by the reciprocal. So I'm going to multiply by 2. Right? Multiply this by 2. Multiply this by 2. Y is greater than or equal to negative 2x minus 8. Notice I shifted my graph down so that I could fit it. All right? Because I got that y-intercept of 0, negative 8. So I had to shift my graph down. So notice your origin's way up here. All right? We see our origin at the top. I'm going to graph 0, negative 8. And then with my negative slope, negative 2. Solid or dotted line? Solid. Shading above or below? Y is greater than. So I'm going to shade above. Let's graph the other one. Y is less than or equal to negative 2. What type of line is that going to be? Horizontal. Solid or dotted? Solid. So y is less than or equal to negative 2. Shade above or below? Y is less than. Below. We'll do this. And because it's an intersection, because it's a union, that's all of it. All of it together. So everything that's highlighted is a solution to the union. Okay? And again, I know it's a union because of that or. Any point in that region needs to satisfy either or. One or the other. And it counts as a solution to the union. Remember, intersections are and. What satisfies both? Union, what satisfies either. Now, testing it would be a little tedious if we wanted to see which ones satisfy either or to make sure it's right. So with a union, I recommend testing what it's not. Pick a point that is outside of any of the shaded region and make sure it satisfies neither of them. Yeah. Well, negative 5, 0. 0, negative 5 is down here. Negative 5, 0. Test that point and make sure that it's false for both. Okay? 0, negative 5, 0 should be false for both. All right? So negative 5 plus 1/2 times 0 is greater than negative 4. Is negative 5 greater than or equal to negative 4?
Yes.
No.
Wait.
Yeah, which is good. That's what I want. I want it to be false. Because negative 5, 0 should not be in my solution set. Because it's not worth any of the So that's good. It's good that it's false. That's what I wanted for this one. Y is less than negative 2, so that means 0 should be less than or equal to negative 2. Is that true or false? False. 0 is greater than negative numbers. So this is a false statement, which again, makes me happy. That's what I want. I want it to be false. So you got to think about what that answer should be. That point. Should it give you a true statement? Should it give you a false statement? And see what you're aiming for. Since I know that negative 5 is outside my shading, both of these statements should be false. I validated my expectation, which verifies my shading. If I end up with one of them is true, well, then I need to look at my shading again. Okay? So you got to be really careful about shading your inequality. Now, if you wanted to make sure that your shading's good and you wanted to find true statements, well, then you're going to have to test the point in all three regions. because it's an or, it's an overlap. Anything in this top right is not going to satisfy y equals negative, y is less than or equal to negative 2. But it will satisfy the first one. Anything on the bottom isn't going to satisfy our first one, but it's going to satisfy the second one. Anything on the bottom right is going to satisfy both. But that doesn't tell me whether my union's right or not. That just tells me about my intersection. So you need to be very deliberate about the point that you pick and what the answer should be. Yeah.
Wait, is there a union when it says or?
Yes. Union is or, and then intersection is and. Is or, intersection is and. All right. Any other questions, comments, concerns? Yeah. All right. So your assignment.